How do volcanoes erupt? Deep within the earth, it is so hot that some rocks slowly melt and become a thick flowing substance called magma. Since it is lighter than the solid rock around it, magma rises and collects in magma chambers. Eventually, some of the magma pushes through vents and fissures to the Earth's surface. Magma that has erupted is called lava. Volcanoes are not just random formations, they are intricately tied to the movements of tectonic plates beneath the Earth's surface. Most volcanoes are found along the edges of these plates, both on land and in the oceans. So how exactly does a volcano erupt? What are tectonic plates? What does it else affect? Let's dig deeper. The story of a volcanic eruption begins deep within the Earth. This subterranean world is a hotbed of activity, all governed by the powerful forces of plate tectonics. Imagine Earth's crust as a jigsaw puzzle, composed of large slabs of rock known as tectonic plates. These plates aren't static, they're in constant motion, gliding over hot magma. Now, where the real action kicks in is at the edges of these plates. When these plates move, they can either pull apart, slide past each other, or collide. Each of these movements can lead to the formation of volcanoes, but let's focus on two main scenarios. The first scenario is when one plate is forced beneath another in a process called subduction. Picture this. An oceanic plate collides with a continental plate. The denser oceanic plate is pushed down into the mantle, the layer beneath the crust. As the plate sinks, it melts due to the intense heat and pressure, forming magma. The second scenario happens when plates move apart in a process called divergence. This is common along mid-ocean ridges where magma rises to fill the gap created by the separating plates. In both scenarios, the formation of magma is key. This thick, molten rock is less dense than the surrounding rocks, causing it to rise and accumulate in magma chambers close to the Earth's surface. This is where the stage is set for a volcanic eruption. The magma, loaded with dissolved gases, is under immense pressure. When the pressure becomes too much, the magma forces its way up, creating a path to the surface through cracks and fissures. So, plate tectonics, the grand architect, sets the stage for the dramatic spectacle of a volcanic eruption. But what is this magma and why does it rise? Stay tuned as we delve deeper into the heart of a volcano in our next segment. Magma, a thick flowing substance, is the real star of a volcanic eruption. Now let's delve into how magma from its formation deep within the Earth to its explosive arrival on the surface. Imagine the Earth's interior as a giant oven, hot enough to melt rocks. Sounds intense, right? Well, that's exactly what happens. When rocks melt deep within the Earth, they form this thick, gooey substance we call magma. Magma is like the underdog of a story, starting its journey in the depths of the Earth, under immense pressure and heat. But it's not content to stay there. Due to its lower density compared to the surrounding rocks, magma begins to rise, defying gravity and the enormous weight of the Earth's crust above it. As magma rises, it's not alone in its journey. Dissolved gases within the magma form bubbles, kind of like the fizz in your soda when you open the bottle. These bubbles increase the pressure within the magma, giving it the extra push it needs to continue rising. It's a tough journey. Imagine trying to swim to the surface of the water while carrying a backpack full of rocks. That's kind of what magma goes through, except it's rocks all around, and the pressure is immense. But magma is persistent. It continues to rise, pushing and nudging its way through the cracks and crevices in the Earth's crust. And as it gets closer to the surface, the pressure decreases, allowing the gas bubbles to expand. This expansion of gas bubbles is what eventually leads to the explosive eruptions we associate with volcanoes. So we've got magma making its way to the surface. What happens next? Hold on to your seats because the eruption is about to begin. Now comes the part you've been waiting for. The eruption. It's a breathtaking spectacle of nature's raw power, but there's a lot more to it than just a burst of lava. Let's break it down. A volcanic eruption is the grand finale of a complex process. Magma, that thick flowing substance formed deep within the Earth, has been on a journey, rising and collecting in magma chambers. The pressure builds and finally, it's showtime. Now, not all eruptions are created equal. Depending on the composition of the magma, we can see two main types of eruptions, explosive and non-explosive. Explosive eruptions are the ones we often see in movies, complete with fiery clouds and flying debris. In these eruptions, the magma has a high silica content, giving it a thick, sticky consistency. This magma traps gases, building up immense pressure until it's released in a dramatic explosion. The eruption can spew hot tephra, fragments of rock and lava, high into the air, creating those iconic towering ash clouds. These eruptions can be incredibly destructive, obliterating everything in their path. On the other hand, non-explosive eruptions are a bit more relaxed. The magma in these eruptions has less silica, making it more fluid. This allows gases to escape more easily, resulting in a gentler, oozing flow of lava. Though less dramatic, these eruptions can still reshape landscapes and create new landforms. So, that's the dramatic spectacle of a volcanic eruption. But do all volcanoes behave the same way? Well, stick around and we'll dive into the diverse world of volcanoes in our next segment. Not all volcanoes are created equal. This might seem surprising, but volcanoes come in a variety of shapes and sizes, each with a unique style of eruption. The type of volcano primarily depends on the composition of the magma it spews. First up, we have shield volcanoes. These are broad, dome-shaped volcanoes with long, gently sloped sides. The magma that forms shield volcanoes is low in silica, making it less viscous and allowing it to flow easily and quickly across vast distances. This results in eruptions that are typically less explosive and more effusive. The Hawaiian Islands, including the Mauna Loa volcano, are prime examples of shield volcanoes. Next, we have cinder cone volcanoes. These are the simplest type of volcano. They're built from particles and blobs of congealed lava ejected from a single vent. The lava is ejected high into the air and then falls back to the ground around the vent, forming a circular or oval cone. Cinder cones typically have a bowl-shaped crater at the summit and rarely rise more than 1,000 feet above their surroundings. Lastly, let's talk about composite or stratovolcanoes. These are the classic cone-shaped mountains that most people picture when they think of a volcano. They're built up by many layers or strata of hardened lava, pumice, and volcanic ash. Unlike shield volcanoes, the magma in stratovolcanoes is high in silica, making it thicker and more viscous. This leads to more explosive eruptions. Mount Vesuvius in Italy and Mount St. Helens in the United States are examples of stratovolcanoes. Each volcano is unique with its own style of eruption. It's this variety that makes the study of volcanoes, or volcanology, so fascinating. Volcanoes. They're more than just fiery mountains. They're a window into the workings of our planet. Today we've delved into the fascinating world of volcanoes, exploring the role of plate tectonics in their formation, tracing the journey of magma from deep within the earth to the surface, and distinguishing between the various types of eruptions. But remember, while volcanoes can be destructive, they also contribute to the creation of new landforms and are an essential part of Earth's geological activity. So now that you know how volcanoes erupt, have you ever wondered what it would be like to witness a volcanic eruption? Share your thoughts in the comments below.